Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on proportions. Note this is designed to be viewed after confidence intervals and hypothesis testing on the mean, and I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. And we are picking up in the middle of our series, and we have covered one example on proportions, and now we're ready to look at a second example on proportions. And this is a population of fish, and some of the fish are black-finned and some are not black-finned. We will take a random sample of 6 fish. The first step is to number the fish in your population. And notice you do not have to number your fish in the same order that I did. If you're following along on the screen, of course, you'll number them my way. If you have a handout or something with these fish on them, you may number yours differently. Next, take a random sample using the TI-84 or TI-83. Remember that if you did this on your calculator, as you're following along, that you will not get the same fish that Mrs. Borlaug got on her screen. So we will use random integer, and since our fish are numbered 1 to 17, we will go 1, 17, and then press enter. And we will press enter until we get 6 distinct numbered fishes. We will ignore any repeats if they occur. And again, remember that you will not get these exact same numbers that Mrs. Borlaug get if you try this on your calculator. And also remember that I do have a video explaining how to do random samples that you can go back and watch if you need some help with this. After you have done that, you can circle the fish that you got for your random sample. This is a population of fish. The sample is circled, and a success is black-finned. So the class activity will be to find the following: P and Q and P hat and Q hat. Now, what do the selected sample of fish tell us? Well, they would tell us our sample. For Mrs. Borlaug's sample, we have circled or sampled 6 fish, out of which 4 have black fins. So for your class activity or quiz for Mrs. Borlaug is to fill in the boxes here, and to remember that P and Q are for your population, which would be for all 17 fish, and that P hat and Q hat are for your sample and are for just the circled fish. So for our 6 circled fish, remember we said that there are 4 have black fins, and a success is black finned. So P hat would be 4 out of 6, and I'll let you figure out the decimal for that. And Q hat would be 1 minus P hat. For P, that would be for the entire population. And like I said, I'm giving you the answer here, folks, would be the number, not just the circled, but the entire population. So you will count the number of black-finned, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think I did that. Let me count real quick again. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 9 out of the 17 for P for your population. And so that's my hint to get you started on your class activity there. So let's look at the circled, we'll circle the correct answer. P is the population proportion. P hat is the sample proportion. And P hat is the same as P? False. But hopefully it is close. It is an estimate of P hat is an estimate of P, and we hope that it is close to P. Now we're ready to answer the question, when may a binomial distribution be approximated reasonably well by a normal distribution? So we will look at two examples. We probably won't get through both examples on this video. So we will start with this example. N equals 31, P equals 0.45, Q equals 0.55, and X equals 0.12 all the way up through 31. And this is what the probability distribution would look like for that binomial. For N equals 8, P equals 0.85, and Q equals 0.115, and X equaling 0.12 all the way through 8, this is what the probability distribution would look like. Looking this one, the first one we can see it has a fairly normal shape. If we look at that, we can see reasonably well that that can be approximated by a normal distribution. But for the second one, we can see that it's skewed and that it cannot be approximated by a normal distribution. But how could we decide whether a normal approximation is appropriate without looking at the graphs? For Mrs. Borlaug, she will look at the products of N times P and N times Q. N times P would be 31 times 0.45, which would give us 13.95. And N times Q to give us 31 times 0.55, or 17.05. N times P in the second one gives us 8 times 0.85, and N times Q gives us 8 times 0.15. Giving us 6.8 and 1.2 respectively. Both NP and NQ are greater than or equal to 5 in our first example, and NP and NQ are not greater than or equal to 5 in the second example. Again, let me read that. I'm not sure I said that right. Both NP and NQ are not greater than 5. One is and one's not. And that's the criteria that we will use. So an important result for us is that if both N times P and N times Q, both of them have to be greater than or equal to 5. If that is true, then the binomial distribution can be approximated reasonably well by a normal distribution. That is our check. So we multiply N times P and N times Q, and if those products are both greater than or equal to 5, then we know that we can approximate with the normal distribution our binomial distribution. Some teachers and texts use a different formula. So your teacher may use the formula that's on the screen now, which is N times P times Q. Instead of using the two formulas, they've combined them into one formula. And that formula is N times P times Q is greater than or equal to 10. Now, I do not like to confuse students, but here at Walters State, the math faculty use one or other of the sets of formulas, not both. And I will use all of my examples. I will stick to the way Ms. Borlaug did them because that's the way she set up these PowerPoints. You will need to check with your instructor to determine which one they prefer you to use. Mrs. Borlaug uses the N times P. I'm going to stick to that. But if your teacher uses the formula that's on the screen now to say that if it follows this setup, then you can reasonably estimate, it's not a hard change. And I just wanted you to be aware that there are other criteria that your teacher may use. If you're a Walters State student, feel free to come by and discuss that with me. We'll get you set up, make sure that you're all on board and you're ready to work with that. This is a great place to start because it says we will now learn how to create a confidence interval. But so instead of starting something new at this point, we're going to pause here and we will learn about how to do confidence intervals in the next video.